Have you ever built a Java app and it just felt clumsy, slow, a bit messy with its data, or totally cut off from everything else? Well, today we're going to fix that. We're diving into the power tools that take a basic app and make it truly professional. We're talking about making it faster, way smarter about its data, and hooked into the wider world. Let's jump in.
So here's our game plan. We'll kick things off with a quick guide to concurrency, then get personal with the life of a thread to see how we can make our apps feel instantaneous. After that, we'll open up Java's data toolkit and figure out how to choose the perfect collection for any job. And finally, we'll connect our app to a database to make its data last.
All right, first things first. Let's tackle that one problem that drives every single user crazy, the frozen application. Our mission here is to make our app feel quick and responsive, even when it's doing some heavy lifting in the background. Oh, you've totally been there, right? You click a button to download a big file, and suddenly the whole user interface just locks up. That infuriating pause, the spinning cursor, that's the classic calling card of a single-threaded app that's completely overwhelmed. The fix for this is something called multi-threading. And honestly, the best way to think about it is like a highway. On the left, a single-threaded app is a one-lane road. The first car has to finish its journey before the next one can even start, causing a massive traffic jam. But on the right, a multi-threaded app is a superhighway with multiple lanes. All the cars or tasks can move at the same time, and everything just flows smoothly. Now, to really nail this down, picture a restaurant. A process is the whole restaurant, the building, the tables, the kitchen, everything. It's a big, self-contained operation. A thread, on the other hand, is like a single chef working inside that kitchen. The beauty is you can have multiple chefs, multiple threads, all working in the same kitchen, sharing the same ovens and ingredients to pump out food way, way faster. And the payoff here is just huge. Your app's user interface never freezes, so it always feels responsive. All those threads are sharing memory, which makes them super efficient and way cheaper for your system to create than firing up a whole new process. Plus, and this is a big one, you get to use the full power of modern multi-core processors. It's really all about doing more work more efficiently. Okay, so we're sold on why threads are awesome, but let's get a little deeper and look at how they actually live and breathe. Because every single thread goes on its own little journey, from the moment it's created to the moment its job is done. Now, this diagram shows something really important. A thread isn't just on or off. No, it's much more nuanced. It actually transitions through a bunch of different states during its life. It's born, it gets ready to work, it works, it might take a break, and then it's done. Let's follow along. So here's how it plays out. First, a thread is born into the new state. Then, when you tell it to start, it moves to runnable. Think of this as standing in line, ready to go, just waiting for the CPU to call its number. Once it gets picked, it's officially running and executing its code. Sometimes it might have to wait for something, like a network call, and it'll become blocked. Finally, when its task is complete, it enters the dead state. Its journey is over. Okay, but, and there's always a but, isn't there? When you have multiple chefs running around the same kitchen, using the same salt shaker at the same time, things can get messy. When multiple threads try to read and write to the same piece of data simultaneously, you open the door to some seriously weird problems like data corruption. This table shows a total disaster in the making. Just watch this. Both thread 1 and thread 2 start by reading the exact same balance of 1,000. Thread 1 adds money, but before it can save the new total, thread 2 subtracts money based on the old balance. Then they both try to save their results, one overwrites the other, and whoops, the final balance is completely wrong. That's a classic race condition, and it's a nightmare for developers. So how in the world do we prevent this chaos? The answer is a beautiful concept called synchronization. You can think of it as putting a lock on that shared piece of data. Only one thread can get the key and access it at a time. It's basically telling the threads, hey, form a single file line, one at a time, please. This ensures our data stays accurate and consistent. Awesome. So our app is now lightning fast and responsive. But what about all the data it's juggling? That brings us to the next stop on our tour, the amazing Java Collections framework. So what exactly is this thing? You can think of the Collections framework as a professional-grade toolkit full of data structures. Instead of you having to build your own lists or sets or maps from scratch, which is really hard to get right, Java just gives you these powerful, pre-built, super optimized containers to store and organize your objects. It's all about not reinventing the wheel. Let's take a quick look at the blueprint here. The whole framework is this neat hierarchy. You've got these big general ideas at the top, like collection and map. And underneath them, you get more specialized tools like list, set, and queue. Each of those then has different implementations, like ArrayList or HashSet, that are fine-tuned for very specific jobs. Let's just focus on the big three for a second. A list is for when the order of things matters, and it's totally cool with duplicates. Think of a playlist. A set is the opposite. It doesn't care about order, but it absolutely will not allow any duplicates, perfect for tracking unique users. And a map is your go-to for key value pairs, just like a dictionary or a phone book. Knowing the difference between a list, a set, and a map is step one. But the real magic happens when you pick the perfect implementation for what you're trying to do. It's like knowing you need a screwdriver, but then choosing between a Phillips head and a flathead. Let's take ArrayList and Vector. They're both lists, right? But ArrayList is super fast because it's non-synchronized. It's built for speed in a single-threaded world. Vector, on the other hand, is synchronized. It's thread safe right out of the box, which connects back to what we were just talking about. But that safety comes at a performance price, which is why Vector is mostly considered a legacy class these days. So you've got all this data in your collections. How do you sort it? Well, Java gives us two main tools here. Comparable is what you use to define the one, single, natural way to sort your objects. Think about sorting a list of people by their age. That's a natural order. But what if you then want to sort them by last name or by height? For that, you use a comparator, which lets you create as many custom sorting rules as you want. Okay, we've made it this far. Our app is fast, its data is beautifully organized. But there's one last problem. What happens when you turn the app off? All that data in memory just, poof, it vanishes. For our final act, we need to make that data permanent. We need to connect to a database. And this is where JDBC comes to the rescue. JDBC, or Java Database Connectivity, is basically a universal translator. It's a standard API that builds a bridge from your Java app to pretty much any database out there. MySQL, PostgreSQL, Oracle, you name it. It lets you write your database code once and have it work everywhere. Now, the drivers that make this bridge possible have gotten way better over time. We started with these clunky Type 1 drivers, but now the standard is the Type 4 thin driver. Why is it so great? Because it's pure Java, it talks directly to the database, and it's by far the most efficient and easy-to-use option out there. And you know what? Actually, connecting to a database follows the same simple 5-step recipe almost every single time. You load the driver, create the connection, create a statement, execute your query, and, this is absolutely crucial, you close the connection to release those resources. It's a reliable pattern, and it's a place where you really need solid exception handling just in case something goes wrong. And there you have it. We've used concurrency to make our app feel alive, the collections framework to organize its brain, and JDBC to give it a permanent memory. These are some of the most powerful tools in the entire Java ecosystem. So now that you have them, the only question left is, what amazing problem are you going to solve next?